Some have envisioned a concentrated laser beam directing energy at the sail.
Eventually, and sadly, this hang glider and all hang gliders at some point have to land. But a solar sail riding a beam of laser energy could conceivably travel to the stars.
The max speed of a solar sail? About 10% the speed of light. Travel from Earth to Alpha Centauri using laser-generated photons? About 45 years. Currently, NASA and other space agencies have plans for launching more solar sails. But there are other, more powerful sources of propulsion in the universe.
In the 1960s, a method of propulsion was proposed where a spacecraft would literally drop a series of explosive charges out the back, and the force of the explosions would push the spacecraft forward. The prototype was called the Orion drive, and there were actually a series of experiments done with conventional charges to show that it would work. The Orion drive, however, was proposed to use nuclear charges.
In order to simulate an Orion-style propulsion system, Paul and Jim here are rigging up a demonstration of and put a small chemical charge inside this barrel in order to lift this off the ground 50, 60 feet in the air. We're going to actually calculate the energy released from this explosion and compare it to a nuclear charge in white powder and actual Orion spacecraft.
The Orion spacecraft simulator is rigged and ready to go. We're going to light off the charges inside, blow the can up into the air, and compare that with the energy released from a typical nuclear explosion that would be used as a Orion-style drive.
The Orion spacecraft, studied at Los Alamos in the late 1950s, proposed nuclear fission as its propulsion source. Fission energy is produced when the nucleus of an atom splits into smaller parts, producing neutrons that release tremendous gamma-ray energy.
The explosive charge of this 35-pound barrel lofted at about 60 feet in the air. A small nuclear charge in the Hiroshima range would liberate about 27 million times more energy. Clearly, that's a practical propulsion drive for interplanetary or even interstellar travel.
Because of the huge explosions that an Orion drive would require, the practical spacecraft would have a huge thick metal plate that would absorb the thrust of the explosion and certain shock absorbers to keep the crew from getting jolted each time the charges went up.
The max speed of a nuclear-powered fission spacecraft? About 5% the speed of light. Travel time from Earth to Alpha Centauri? About 90 years. Despite its powerful fuel source, the fission craft is actually slower than a solar sail. Boosting speed would mean turning to another, more intense nuclear reaction.
Fission technology is well known and understood, and we've been using it to generate power here on Earth for decades. But there's another kind of nuclear technology, and that's nuclear fusion.
Fusion is the power source of the sun. In the core of our sun, temperatures are so high, atoms are moving so fast that they slam into each other, creating new elements and liberating energy.
The opposite of fission, fusion energy is produced when two atomic nuclei fuse together to form a single heavier nucleus. The result is a huge liberation of energy. A fusion-powered spacecraft was proposed in a 1970 study called Project Abends. Its mission called for a trip to Barnard's star, some 5.9 light-years distant. Instead of nuclear bombs, the fusion-powered craft creates the propulsion on board in a reaction chamber.
The fuel pellets for the Abends class consisted of pellets composed of deuterium, helium-3 mix. These would have been ignited by what is called relativistic electron signatures, extremely high-energy electrons that would have hit the deuterium-helium-3 pellets, caused them to fuse, and a huge amount of energy would be released. The Daedalus design called for 250 of these pellets to be released every second for over 2 years. The spacecraft would have weighed 55,000 tons, most of which would have been fuel.
The weight penalty for such a spacecraft would be high, but an advanced civilization could eliminate the problem by mining the hydrogen fuel during its interstellar journey. Deuterium, or heavy hydrogen, exists in abundance on Earth, notably in seawater. But helium-3 is a much rarer isotope. In our solar system, it can be found on the Moon, and in vast quantities on Jupiter and Saturn. The scientists have proposed using huge hydrogen scoops to mine the helium-3 across the middle of space.
So it's conceivable that if you had a craft that was powered by nuclear fusion, you could go to another star system and then use the hydrogen available from that star to refuel.
The self-contained, fusion-powered spacecraft could avoid huge weight penalty and reach speeds that could allow near-star the max speed of a nuclear-powered fusion spacecraft, up to 15% the speed of light. Travel time from Earth to Alpha Centauri, about 35 years. The immense costs, logistics, and even the politics of nuclear-powered spaceflight long ago caused humanity to scrap any and all plans. But a sufficiently advanced society could trade nuclear propulsion for what seems like an impossible paradox, traveling at light speed without moving at all. UFOs actually achieve the immense speeds required for interstellar travel. One potential answer may be buried 30 feet beneath the ground in America's heartland. The Fermilab Tevatron Collider, outside Chicago, Illinois. Racing just below the speed of light, particles of protons and antiprotons are launched in opposing directions. They meet in a high-energy collision. The impact produces gamma rays, the highest energy source known in the universe, and potentially the key for interstellar travel.
The best way of making antimatter here on Earth is to employ probably the most famous equation of Einstein, E=mc², which tells us that for a certain amount of matter we can get energy. It's a great idea because it's incredibly efficient. You essentially take all of the mass in those particles and convert it into energy.
But how can antimatter exist in the universe if it must be artificially manufactured? That's the question that Stephen H. from Philadelphia texted the universe.
Stefan, antimatter definitely exists, and when it meets up with normal matter, it explodes in a burst of electromagnetic radiation. Now, we can make small bits of antimatter in laboratories, but we can also collect antimatter from space. Some cosmic rays, which are charged, very energetic particles coming from space, actually consist of antimatter.
Currently, the super collider is the only practical way to produce antimatter. And right now, it's created in very small quantities.
If we could figure out a way to both create and store enough antimatter, we would have a storeable fluid which, when mixed with ordinary matter, would liberate a huge amount of energy at a rate way beyond what either fission or fusion can do.
Because we know antimatter exists, and we know antimatter can be created and stored, it is conceivable that an advanced civilization could create and harness the power of antimatter in sufficient create an antimatter rocket.
An antimatter ship could achieve unbelievable velocities, cruising just below light speed. You can imagine the speed of a starship across the galaxy. Travel time from Earth to Alpha Centauri, 4.5 light years distant, about 5 years. In human terms, the cost of creating enough antimatter particles to power such a starship would be astronomical. It might be affordable in alien currency, but an antimatter spacecraft like this comes at a high price. The gamma rays from antimatter propulsion are so dangerous, they could destroy the cell structure of any living beings aboard ship. This starship has advanced shielding and at such high distance speed, there are equally destructive threats.
Space is pretty empty, but if you were moving close to the speed of light, you'd need an extremely effective shielding system that would allow you to be protected from interstellar dust particles that would all but annihilate a spacecraft traveling that fast.
But if space debris is so dangerous, why not avoid it? The solution might be one familiar to Star Trek fans, namely a starship that could achieve light speed without even moving.
In effect, one would create what is called a warp bubble. Named straight out of science fiction, and that would involve pressing a region of space-time in front of a spacecraft, expanding a region of space-time behind the spacecraft, while the spacecraft itself sat stationary inside this flat bubble. One would effectively be riding away from space-time.
A warp drive may seem like pure sci-fi fantasy, but in 1994, a well-respected young physicist named Miguel Alcubierre published a serious proposal outlining how to travel in a controllable space warp. There are huge obstacles to Alcubierre's warp drive solution. The biggest is called dark energy. A cosmic phenomenon recognized in 2011 when 3 scientists were awarded the Nobel Prize for proving its existence.
The simplest explanation that's been proposed for the phenomenon of dark energy is that there's an intrinsic property of space itself that makes it want to expand. You can actually see it by looking at the seeding parts of the universe and seeing that there's this extra acceleration. But it isn't stored in an energy source like solar energy or other kinds of energy.
And so it's not inconceivable, it's not beyond the realm of possibility that some advanced civilization existing somewhere in the universe has learned how to harness dark energy to create an specific form of propulsion.
But there's another obstacle to a workable warp drive. The only known way to pull a spacecraft forward within a warp requires harnessing the intense energy of a black hole.
The sort of simple notion is somehow to make a very concentrated bit of matter, extremely concentrated on the level that would cause a black hole. If you could generate a black hole on a small scale, so to speak, you could dangle it on your ship and use its space distortion to sort of drag the ship along.
And exactly how fast could a warp drive go to rescue a spacecraft?
The clear implication of Alcubierre's work was that it should be possible to make this design of a warp drive to achieve speeds almost any multiple of the speed of light.
Travel time from Earth to Alpha Centauri aboard a lightspeed craft powered by a space warp? About 4.5 years. Or less, as long as everyone on board doesn't incinerate.
One problem with the Alcubierre drive is that in that warp bubble, everything rise to far hotter than the core of our sun. That's not.
Just one more small problem to solve. Just reach. But what if such an alien spacecraft were to arrive at Earth's atmosphere, riding in a warp bubble towed by a black hole? It might not be the first mass witness UFO sighting, but it would certainly be the last. March 13, 1927. Thousands of people witnessed the optical phenomenon drifting across the Arizona skies. Reports of a series of bright lights in geometric patterns are widespread, including multiple sightings over Phoenix of a craft up to a mile wide with lights winking on and off in sequence.
Reconstructing the events of that evening, the lights of the Phoenix spikes were almost certainly flares dropped by an Air Force A-10 aircraft in conjunction with the human tendency to envision a solid shape of atmosphere. That's the best explanation of the Phoenix lights.
For many, the Phoenix Lights incident was direct proof that a huge extraterrestrial craft had arrived. Some even called it a mothership. The purpose of an extraterrestrial mothership is fundamentally the theories of alien visitation. It's the only way to bridge the vast distances in space.
Alien beings around the same time as flying saucers as the term came in. And I think the universal notion was you couldn't make an interstellar trip in a person-sized craft. You have to have something really large.
An apt earthly analogy of a mothership is that of an aircraft carrier. An aircraft carrier travels the vast distances across the ocean, but its purpose is to transport smaller aircraft, then go on and engage in whatever their missions may be.
If the journey to Earth is long, on the order of centuries or even millennia, the mothership would be much more than just an aircraft carrier.
There's the generational or ARC ship, which is a very large spacecraft that is essentially an enclosed ecosystem in which generations of inhabitants expected to be born, grow old, and die over a long period it takes the spacecraft to reach its ultimate destination.
Perhaps with technology such as suspended animation, biological alien passengers could be put to sleep and revived after a fast journey. Surviving such a journey would also mean surviving the destructive energy powering the space station itself. One logical design solution, a cigar-shaped mothership, is precisely what many UFO witnesses claim to have seen.
For any advanced propulsion system, you would want to situate the crew as far away as possible from the engine source. So one possible design would be a very long synthesizer with the engine located at one end of the spacecraft, and some kind of truss connecting the crew section as far away as possible so as to avoid damage from high-energy neutrons, X-rays, or gamma rays from the environment.
If such hardships had in fact visited planet Earth, the evidence would be overwhelming and undeniable.
Something all these exotic and advanced propulsion technologies have in common is that they all radiate prodigious amounts of energy, and so we'd be able to see them like beacons on a lighthouse, sometimes light years away.
A concentrated emission of X-rays, gamma rays, or subatomic particles would be suspicious because we don't see that in our environment locally under normal circumstances.
Beyond the obvious visual evidence, the physical effect of a mothership approaching so close to the Earth's surface could be a terrifying form of apocalypse.
If for whatever reason this extraterrestrial technology or civilization chose not to turn off their engine, it could be catastrophic for life on Earth as we bathe in high-energy neutrons, X-rays, and gamma rays.
If it's something which is a version of a warp drive, then you're talking about space distortion. And you wouldn't want to be too close to any major mass, including the planet.
Such catastrophic visitations assume that aliens are willing to risk their own lives in interstellar space. But there might be a better way. stay at home and explore the cosmos using a race of thinking machines. For many ardent believers in the UFO phenomenon, the Roswell, New Mexico event in the summer of 1947 is the defining alien encounter in human history. In popular culture, the most lasting detail from the purported crash came from the descriptions of extraterrestrial bodies found at the scene. In the ensuing decades, this vision of alien beings, known as the Greys, became the accepted standard of science fiction encounter reports. Oversized heads may explain an expected feature in alien biology: greater intelligence. The larger skulls would contain larger, more advanced brains compared to ours. Certainly require great intelligence. But might it require something that is beyond organic biology?
One area of science fiction where we might be making kind of a big mistake is to assume that the aliens are biological, that they're living things.
I think that the possibilities for the kinds of organisms which might travel between the stars are really wide open. And one possibility that has appeared on occasion in science fiction is machine intelligence.
According to a recent earthly equation known as Moore's Law, the number of transistors on a single computer chip doubles every 18 months, meaning computer processing speed doubles. This trend has continued for more than half a century and is expected to continue through 2020 or later. The exponential explosion of processing speed is opening the door on stage science fiction for artificial intelligence.
If you invent a thinking machine 100 years later, and that machine is not only smarter than you are, it's smarter than all humans that have ever lived. And that's the difference between artificial intelligence and real intelligence. Artificial intelligence can evolve enormously fast. And I think the form of AI that we find most both menacing and promising is the kind of AI that could, in fact, do what our brains do. Think the way we can think.
At Stanford University's Artificial Intelligence Laboratory, the future of truly intelligent machines is rapidly approaching.
There are a few things that make AI difficult. One is we don't really know yet how to make computers learn as effectively as humans can. It seems that computers today just aren't as fast as we would like them to yet to simulate the learning processes that take place in the human brain.
To demonstrate early-stage artificial intelligence, Stanford students designed a fighting robot, one that attempts to learn as it fights.
Okay, so what it's doing now is trying to defend itself. So it's reacting to your motion. So depending on how you move your sword, the robot will adapt to your motion and to your behavior.
How important a step on the road to true artificial intelligence robots like this?
So here we are using video method, like learning method, to adapt to the environment of the robot. But we are still not at a stage where the robot is really thinking.
Today's computers are still far less intelligent than a human. But in the future, I think computers could eventually reach and maybe even surpass human intelligence. And if that's the case, imagine that each of us had a computer or a cell phone together that was as smart as Einstein or even smarter. How would civilization change? What would be amazing things to do?
Advanced as it is on Earth, the fencing robot is but a crude analogy for the type of machine intelligence that could pilot an interstellar spacecraft. The immense obstacles of space travel, including the sheer timescale and cosmic hazards, build a strong case that a race of intelligent machines will make first contact.
But honestly, interstellar travel really takes place it seems sort of reasonable to not send the biological beam. I mean, they're fragile. They have finite lifetime.
Just as NASA sends robotic probes to explore the solar system in advance of human explorers, our first contact with an alien civilization may be with its robotic probes.
Biologic beam or AI super beam? Our vision of an extraterrestrial will remain mere speculation. And despite a lack of hard evidence, just how likely is the existence of an intelligent civilization? Some believe it is highly likely that the universe teems with life.
The galaxy has been around for a long time. The solar system has been around for quite a long time. It's a galaxy much known. And the stars in it, many of them are much older than the sun and our solar system. So the chances are civilizations are out there. They've been around for longer than we have. If they exist, say, for 100,000 years, then the chances are pretty good. I think they will have learned to either communicate across interstellar space or possibly
Until first contact occurs, humanity will continue to scan the skies for UFOs. None have proven to be extraterrestrial craft so far, but that does not rule out the possibility that humanity may one day discover evidence of an intelligent civilization, either in the far-flung heavens or much closer to home. In space, no one can hear you screaming. As the promo line for Ridley Scott's science fiction film Alien, it was designed to send chills down your spine. It's based on the unsettling idea that space is a vacuum and sounds, screams, shouts, and songs can't travel in a vacuum. Is that really true?
Space you can't hear from the screen. Because in fact, here on Earth, there are lots of sounds we can't hear. They're either too high a pitch or too low a pitch. Moreover, space isn't completely empty. And then finally, what's the definition of space? If I'm an astronaut on the surface of Mars and I have a spacesuit on, am I in space or am I not? Well, I would think I am.
Okay, let's try right over here.
Back on Earth, Bruce Betts of the Planetary Society in Pasadena, California, has given a lot of thought to Mars and the subject of sound. He's programmed his computer with what he calls the Mars Cable to demonstrate the recorded sound level in the cold carbon dioxide atmosphere of Mars without those space suits.
The atmosphere of Mars